All right. Hello, everybody, and welcome to Building Planet-Scale.NET Apps with Azure Cosmos DB. I'm Justine Cocchi, and I'm a program manager on the Cosmos DB team. I focus on developer experiences, including working with our .NET SDK, our Go SDK, change feed, the dedicated gateway, integrated cache, and a ton of really cool Cosmos DB features. So today we're going to be talking about scaling and building apps, but first I'm curious, how many of you, by a show of hands, have used Cosmos before? Okay, probably about half. That's great. So today we'll talk about a lot of Cosmos DB concepts and features and how you can really build performant applications. Modern apps today have a lot of complex data needs. You need consistent performance. As your application scales, you want to make sure that your performance maintains constant. You don't want your performance to degrade as your app gets bigger. The whole point is to grow, right? So we want to help you do that really seamlessly. You want to make sure that your application can handle both spikes and dips in traffic. We all know that this is normal, right? Hardly any applications have a completely constant request pattern, but we want to make sure that as you have spikes and dips, you're not over-provisioned or overpaying. And you also want to make sure that when a sudden spike comes, your database can react and can actually respond to that spike. And you may have global users. You want to make sure that as your application grows and you begin to scale, that your application remains performant regardless of where your users are. You don't want one side of the world to be more performant than the other. So if all of these problems sound familiar to you, you may be interested in Azure Cosmos DB. Cosmos DB is a fast, flexible, distributed database with multiple APIs that you can program against. There's the NoSQL API, but we also have APIs for MongoDB and even relational APIs with Postgres. What all of them share is the scalability. So Cosmos DB really shines in its scale out. We have infinite scale out with zero downtime. This means as your application scales, Cosmos DB will grow with you, and you don't need to pause your business application in order to do it. Because it's a distributed database and we scale out, this allows you to have consistent read and write latency as you scale. So your point operations are guaranteed to remain performant, even as you're adding more partitions, adding more data, and having more complex operations. We offer latency and availability SLAs to guarantee the speed and performance. For our latency SLA, point operations are guaranteed to have less than 10 millisecond latency. And for availability SLA, if you have multiple regions configured, you're guaranteed to get 5 nines of availability. This is really critical to what Cosmos DB is as a product, right? It's a mission critical database ready for any scenario. We also offer seamless global distribution. I'll show you just how easy it is to configure extra regions in your account and automatically have that data replicated for you. There are many mission-critical security, analytics, features with Azure integrations, and many more. We definitely can't dive into everything today. We're going to be focusing today on scaling and building apps. But as we walk through this talk, I want you to think about some of the scenarios maybe in your own applications, in your own day-to-day work. Cosmos DB is a great fit for many industries, many scenarios, from AI, like ChatGPT, which is storing all of its chat history in Cosmos DB, to IoT, manufacturing scenarios, retail, and more. All right, so let's talk about how Cosmos DB actually scales. When you create your Cosmos DB account, you can add multiple databases, and inside of each database, you can add multiple containers. And the container is really the unit where all of your data lives in Cosmos DB. So with your container, you're going to start with at least one physical partition. So what is a physical partition? This is the unit that actually is storing your data. And one physical partition can serve 50 gigabytes of data or 10,000 RUs. Now, 10,000 RUs, RU stands for request unit, and it's basically an abstraction of the amount of throughput that your application can handle. So a 1-point read of a 1 kilobyte document costs about 1 RU. So that's kind of the measurement of what an RU is. If you're doing a write operation of a 1 kilobyte document, it's probably going to cost somewhere between 5 and 7 RUs. So this is great. I have a physical partition, but what about the scale out, right? I maybe need more than 50 gigabytes and I want more than 10,000 RUs. So Cosmos DB just simply provisions more partitions under the hood and will distribute your data. So as you add more data, Cosmos DB will automatically detect when it needs to split a physical partition, and it will create 2 new partitions and split your data into both of them. So this is how Cosmos DB scales. Similarly, if you increase your request units and you ask for more throughput, Cosmos DB will split some of your partitions and will be able to provide you extra throughput. All right, so let's talk about partitioning and partition keys. So as you have a distributed database, you have multiple physical machines, of course, you need to tell the system, which data goes on which machine. And how do we determine that? That is done through partitioning. Partitioning is a really important concept for performance in Cosmos DB, and it determines a couple of things. First, it determines how your data is physically distributed on all of these machines. So let's recap a couple of terms before we dig into this. We have physical partition. So this is the unit that we were talking about that's storing your actual data, right? Each physical machine owns a range of partition key values. So this is how it decides which of your data gets mapped to various physical partitions because each one owns that range. So we also have a logical partition. This is the actual partition key value that belongs to one of those ranges. And this is how the distribution of data is actually determined. So let's take an example. We have a manufacturing scenario where we have a bunch of device IDs, and they're all sending data to our account. We have 2 containers, and I've partitioned each container by a different property, and let's see how this affects our application. So in the first example, we partitioned by device ID. Now, in this scenario, we have tons of devices, and they're all sending data roughly evenly, so they all roughly have the same amount of data, and when Cosmos DB gets that device ID, we're going to hash it, and we're going to assign each device ID to one of these physical partitions. Now, because we have a lot of device IDs and they're all roughly sending the same amount of data, when these get assigned to physical partitions, we have a roughly even distribution, right? This looks pretty good. Now, let's look at our second example, which is partitioned by day of week. There's a couple of things that make this a less optimal partition key in terms of data distribution. First, as you can see, there are 7 days of the week. We only have 5 partitions. So that means in the best case, at least 2 of our partitions are going to have way more data than the others. But this is the best case, right? So Cosmos DB hashes these values and assigns them into the partition key range. There's nothing that guarantees that all of your days of week will end up magically on their own partition, right? So in a realistic case, when you have a low cardinality, a low number of logical partition keys, the likelihood that they get mapped in an optimal way is a lot higher. So when you think about data distribution, you want to consider 2 things. You want to pick a key that has roughly the same amount of data for each value. And you also want to pick a key that has a lot of potential values so that when these get mapped to physical partitions, you're more likely to have a good distribution of data. All right, so what about requests? Partition keys also determine how your requests are distributed. We have the same scenario here, our 2 containers, one partitioned by device ID and the next partitioned by day of week. And this time we want to run a query. So my query, I'm going to get all of the data for a certain device ID. So let's look for device ID 123. And we can see here the difference in our query. So it's the exact same query for both containers. But on my first container that's partitioned by device ID, this is a specific query to one physical partition. It's scoped to a partition. We know exactly where to look, and we can get that data and return it in one trip. Whereas the second query, we have to look in all of the physical partitions. We don't know where the data for 123 is, so we need to do a full scan across all of our partitions, and we have to find all the data and then collect it and return it to the user. So this is a lot more expensive operation, and it's resulting in a cross-partition query. In general, we'd like to avoid cross-partition queries, but of course it can happen. There are some scenarios where maybe it's unavoidable to have cross-partition queries, so they're not always horrible, but you definitely want to model your data and choose a partition key that serves most of your queries, where those values are actually appearing in your query. All right, let's take a look at the last effect of partition keys, which is how your throughput is distributed. Now, again, we have our same 2 containers. We have device ID and day of week, and they have that uneven skew, right? So when we provision the number of RUs for this container, let's say we want 25,000 RUs. By default, Cosmos DB actually divides all of your RUs evenly across all of the physical partitions. So what this means is that device ID, it's probably going to work out, right? It looks like we have roughly the same amount of data. We know all of our devices are sending the same amount of requests. So it looks like 5,000 is probably going to be enough to serve this. But for our second container, which is partitioned by day of week, those same 5,000 RUs now are being stretched a lot further, right? We have some partitions that have a lot more data, and we may be querying those a lot more. So while some of our partitions are sitting idle and maybe underusing throughput, a couple of our partitions are likely going to get throttled. So when you think about your throughput distribution, this is why it's so important to make sure that your data and your requests are evenly distributed across your partitions. So let's recap with some characteristics of a good partition key. First, you want a value that doesn't change. That partition determines how your data is physically laid out. So if you're always changing that partition key, you're actually creating new items stored in those new partitions. You want a wide range of possible values. This is also referred to as high cardinality. So day of week has 7 options, where device ID has, limitless, however many devices you actually have in your system. You want to pick a key that has a similar amount of data for all values so that when that data is distributed, all of your partitions roughly have the same amount of data. And lastly, you want to make sure that the key spreads your requests evenly across those values. So we talked a little bit about queries. You want to make sure that you're querying across all of the possible values, but you also want to make sure that your writes are spread across values. So think back to the day of week example. If I'm writing data and I'm partitioned by day of week, every day, Wednesday, all of my data is being written into one partition where those other partitions aren't using their throughput. Maybe you have reads for the other partitions, but typically you're creating a hot partition for yourself. So you want to distribute both your queries, your reads, and also your writes. There's a couple of strategies that you can choose when picking a partition key. The first one is finding a property that's a good standalone key by itself. So in this example, device ID is probably going to work out. But what if I have a multi-tenant application or some application where I can't pick one good key? We have a feature called hierarchical partition keys, which allows you to combine up to 3 properties, and these 3 properties together make up the partition key. This is really helpful when you have a partition key. Maybe you have more data than is allowed for a logical partition. Each logical partition key can only have 20 gigabytes of data. With hierarchical partition keys, this gives you a lot better spread because that top level can have more than 20 gigabytes. So in this multi-tenant example, I have my first level as tenant ID, and then I have user ID, and lastly, I have transaction ID. That tenant user ID, transaction ID set has to have less than 20 gigabytes. But tenant itself can go far beyond that. So this gives you greater flexibility when you're building your applications and also allows you to take advantage of Cosmos DB's scale. The last strategy that you can consider is materialized views. This is when you maintain a copy of data in a different container with a different partition key. Now, there's a couple of ways to achieve this. We have a materialized view builder, which will automatically handle this for you. So you don't need to worry about manually updating your container and keeping the 2 copies in sync. If you do want to have that fine-grained control and you do want to keep your copies in sync, you can use the change feed to do that. And you might be thinking, well, that seems like overkill, storing all of this data a second way. How much is that going to cost, right? In Cosmos DB, storage is a lot cheaper than throughput. So depending on your request pattern, this may actually be a good pattern for you, especially if you have tools to help keep this in sync. And you can really avoid those cross-partition queries. All right, so we talked a lot about scaling within a single container. How does that one container grow and how does that work? But what about global distribution? What does global distribution give you? And there's a lot of benefits of global distribution. The first and foremost is high availability. So remember when we talked about those availability SLAs for Cosmos DB, 5 nines of availability? That is only able to be achieved because of global distribution. So when you add multiple regions to your Azure Cosmos DB account, it allows you to have continuity during regional outages or even transient failures. The SDK can automatically retry certain requests on separate regions, and it gives you that availability even if something is going wrong in your primary region. Global distribution also, of course, gives you low latency. So if you do have users that are geographically distributed and you want low latency for all of them, you can add a secondary region, either as a read region or as a read-write region. And lastly, all of this is done automatically. Cosmos DB provides automatic replication, so data is seamlessly replicated to those regions for you. You don't need to worry about complex jobs and keeping anything in sync. It's all done automatically. So how does this automatic replication work? If you think back to that first chart, when I showed you a container has multiple partitions, that was actually a bit of an oversimplification. So each partition is not one machine, it's actually 4 machines. Each partition is made up of 4 replicas. You have a leader, 2 followers, and a forwarder. These 4 replicas work together to form a replica set. So you see in this example, we have a replica set for our primary region in US West. And that forwarder is the node that is responsible for actually forwarding the data to our other 2 regions to make sure that those 2 regions are in sync. The leader for those gets the data, and then we'll replicate it to the rest of the replicas in that region. So this is how the local replicas within a region work together on the replica sets across regions. Zooming out a bit on what this looks like. So now we have local distribution. We have scaling out of multiple partitions in a container. Each of those partitions gets its own 4 replicas. And we also have global distribution. As you add regions, you add new replica sets for each region. And each set of replica sets that represents one physical partition is combined to make a partition set. Now, this is a lot of terminology, and in practice, you don't actually need to know any of this, but it does help to understand what's happening under the hood when you add regions to help you think about, as your app scales, what's actually happening inside of the database. So as soon as we start adding a bunch of regions and we have all these replicas, you might be thinking, okay, wait, there's so many copies of my data. How do I make sure everything stays consistent and fits my business needs? So Cosmos DB offers 5 consistency modes that you can choose from. And this will really have a bunch of trade-offs. So the first one is strong. If you've used SQL before, any database, you're probably familiar with strong. This offers a linearizability guarantee. And it means that all of your reads are guaranteed to be in order. Now, thinking back to the replicas, the way that we achieve this with strong, in order for a write to be committed, it needs to be committed to all 4 of your replicas in the replica set. And it's not just that replica set. It actually needs to be committed to every single replica in every single region that your account is present in. So this obviously will have higher latency because we need to make sure it's replicated total globally, but it has the strongest consistency. So these are some of the trade-offs. For reads are performed against 2 replicas. And that means that reads in strong consistency do cost double RUs because we're doing double the amount of work to make sure that we get you that consistency. There's a couple of restrictions for strong consistency mode. If you have regions that are farther than 5,000 miles apart, physical distance, this need to have all of the data replicated to every replica in every region becomes a bit of a tax. So you're not able to actually use strong consistency if you have regions that are over 5,000 miles apart. And the other thing to consider is multi-region writes. So multi-region writes with strong consistency doesn't really make sense because all of your writes are going to every region anyways. So a couple of things to consider with strong. Next, we have bounded staleness. So with bounded staleness, your reads are allowed to lag behind either K versions or T time. And this is configurable, so you can configure it to whatever you'd like. But it does have some implications on your write availability. So consider the replication to all of those nodes that you need. If you need to make sure that your reads don't lag behind K updates or T time, it's possible that you can have replication delay that would actually cause a loss of write availability because you're not able to write a new thing until the replication catches up. So depending on your configuration, really consider these bounds and what you actually need in your application and think about those trade-offs. Bounded staleness also reads from 2 replicas, so it also costs double RUs to read in bounded staleness mode, but writes are committed to 3 out of 4 replicas locally. For session consistency, this offers read your own writes guarantees when you have the session token present. If you don't have the session token, it falls back to eventual, which we'll talk about in a second. But for session consistency, reads are performed against 1 replica, assuming that that session token matches. So if the session token doesn't match, it might retry on another replica, or even a cross-region retry to try to get that session token that matches before we return you your data. For session consistency and all of the rest of the consistencies, writes are still guaranteed on 3 of the 4 replicas. Next is consistent prefix. In consistent prefix, you're guaranteed to not get any out of order reads, but you may not necessarily get the latest read. And lastly, we have eventual, which of course is eventually consistent. There's no order guarantees here. So some of the trade-offs for all of these modes, as you go up, the consistency improves. So strong is the strongest consistency, eventual is the lowest. Opposite for availability. Strong has the lowest availability, whereas eventual is the highest. Again, for latency, eventual is going to have the lowest latency, strong will have the highest. And lastly, throughput, lowest throughput with strong and most with eventual. So these are the consistency modes. Some of the trade-offs to think about, especially as you're adding more regions to your account, it's really important to think about what consistency you actually need for your application. All right, so we mentioned multi-region writes, and you might be thinking, wait a second, I have writes coming in from multiple regions. What if there's a conflict, right? There can be conflicts, and we let you fine-tune your conflict resolution policy. By default, the policy is last write wins. So in Cosmos DB, there's a system property called _TS, and that has the timestamp that your document was updated. So with last write wins, we look at the 2 timestamps. We say, what was the timestamp for region A? What was the timestamp for region B? Whichever one was more recent, that's the one that actually gets committed to your database. But you may not want this policy. You might want to fine tune it a bit. So we also have some customizable policies. You can configure a stored procedure to write custom business logic that will perform the merge. So maybe you want to look at the 2 changes, see what changed and try to merge them somehow, or some other business logic according to your application needs. You can go ahead and write the stored procedure. But what if there's an exception in the stored procedure? So for any exceptions that occur in the stored procedure, it falls back to the manual resolution via the conflict feed. So we'll actually give you all of the conflicts available in a conflict feed, and you can manually resolve that however you want. Now, if you do choose a custom conflict resolution policy and you don't configure the merge stored procedure, those conflicts will also go to the conflict feed. So 2 ways to use the conflict feed there. All right, that was a lot of talking. So let's go into the portal and see how this global replication actually works and what it looks like. So I'm just going to pull up the Azure portal. I have my Cosmos DB account here, and I've already configured it with 2 regions. So my primary region is West US, but I've also added Central US as a region. And adding regions is as easy as a click of a button. I could click as many of these as I want and add new region. I'd have to save it, of course. Not going to add new regions now. If I scroll down a bit, you can see if they're configured with availability zones, and you can see if I've used multi-region writes. I haven't used either of those, but also more options for higher availability. But I want to talk about one more thing in the portal that we didn't touch on yet, which is failovers. So as we mentioned, the primary reason to have multiple regions is to give you better availability in a regional outage or disaster scenario. So let's take a look at the failover policy configuration and see what this looks like. So here you can see I have my write region in West US. This is my primary region. And I also have a read region. I only have 1 read region, so the priority is 1. But if I had multiple read regions, you could configure the priority here to determine for yourself, what is the failover priority in this application. And I also want to call out this checkbox here, which is service managed failover. This is extremely important because it allows Cosmos DB to perform a failover on your behalf. So if we were to have a regional outage, this means that we would be able to fail over automatically your right region to the first one in this priority list. And this is really important. It does have a possibility for some data loss, but the service managed failover is a really high bar. So we really want to make sure before we fail over, this is absolutely an outage. And it can take some time to trigger this because we know there's data loss. We know there's implication, rerouting your traffic. Your application may have higher latency. This is a really big bar for the team to take. So what if you know there's an outage? You know your application more than us, better than we do. So if you want to react even faster, you can do something called offline region. And this will basically tell Cosmos DB, hey, I know there's an outage. I need you to offline this region now, and I want you to fail over to the next region in my priority list. So these are the options that you have. The offline region is definitely, you should use this if you know there's a region outage. But what if you don't have an outage and you just want to change your right region, right? This can happen. Your application traffic can change over time. Maybe you used to have a lot of customers in West US, but now Central US is bigger for you and you want to switch that. So you don't have to go through all the offlining. You don't have to subject yourself to potential data loss. You can actually use this change right region feature. And this, we have these checkboxes here because it's really important, should not be used in an outage scenario. This is if there's no outage, but you just want to change your right region. And what this does is a graceful failover. It actually makes sure that all of your partitions have caught up and that replication is totally complete before failing over. So if you change your right region, there's no data loss here. It's just a way to give you more control over the regions in your account and which ones are accepting writes. All right, so enough about the replication and all the configuration available in the portal. Let's flip back into the slides. And at this point, you might be thinking to yourself, I am not sure about all of this. There is so much scaling going on. There's so many regions. I just want to get started. Maybe you've never used Cosmos before. It seems like a really high bar. So don't worry. It is definitely possible to start small and scale up as you need to. We have a lot of options with Cosmos DB. First, you can develop locally with the emulator. So this is free to use, easy to install. You can get started locally just to play around and see what the APIs look like, maybe build a small sample application. And once you get comfortable, maybe you want to get a real account, but you're still not ready to commit and you don't want to pay anything. So we have a couple options for free tier. The first option is called Try Azure Cosmos DB. And this gives you a free subscription for 30 days. And it will let you use this account without even needing an Azure subscription or signing up for any credit card related to your Azure subscription, anything like that, completely free for 30 days. And you can always transition it into a paid account. But what if the 30 days are up and you want to transition to a paid account, but you still don't want to pay, right? We also have a free tier for paid accounts in Azure, and they will be completely free for the lifetime of the account. You can have one free tier account per subscription. And what the free tier gives you is 1,000 RUs and 25 gigabytes for absolutely free. So this is great, but now I'm a little bit more comfortable with Cosmos DB and I want to start developing and testing. And maybe I want to go a bit beyond that 1,000 RUs. So we have the serverless provisioning model. And with serverless, you only pay for what you use. You pay for the RUs that you actually consume, and you're not provisioning anything up front. So with serverless, we give you 1 million RUs for just a quarter. It's a really cheap, awesome option for dev test workloads. Maybe you have a lot of traffic from 9 to 5, but on the evenings and the weekends, there's no traffic. So you don't have to pay for that time that you're not actually using the database. And lastly, we have autoscale. This is part of our provision throughput offerings, and it allows Cosmos DB to automatically scale for you depending on the actual traffic that is incoming to your system. So with autoscale, we allow you to scale up to 10x instantaneously. So this means you can provision an autoscale maximum of 10,000 RUs, but when you're not using them, you only pay for a minimum of 1,000 RUs. When you do see a spike, Cosmos DB can automatically and instantaneously scale up to that 10,000 RUs. And after the spike is over, it'll scale right back down gracefully. Now, we have a new feature called dynamic scaling, which takes this a step further. So think back to that throughput distribution where we saw that each physical partition has the same amount of throughput provision for it. Now, before dynamic scaling, all of the partitions in Cosmos DB across regions scale together. So what that means is if you have a spike, if you have a hot partition in one region, one partition, you would end up paying all of your partitions would scale up to that spike level. With dynamic scaling, it allows each partition to scale independently. So if you have a hot spike in one partition in one region, that's the only partition that will actually scale up to that amount. So dynamic scaling is a really cool, awesome feature. It's been asked for a really long time. I really recommend you guys check it out. All right, so this is a developer conference and I'm ready to start talking about some code, right? We've done a lot of configuration. So if you're interested in Cosmos DB, we have many SDKs, but today we're gonna focus on .NET. And you don't have to go straight to the .NET SDK itself. We have a lot of integrations that are amazing that you can start using. So who's used Entity Framework before? Show of hands. Okay, almost everybody. Great. So we have an Entity Framework provider, and this provider allows you to use the Entity Framework APIs that you know and love and still talk with Cosmos DB. The Entity Framework team is currently doing a lot of great work on this provider. And so you should definitely keep your eye out. We're going to be announcing some really cool updates. A lot of things are coming here, like RBAC support for hierarchical partition keys, better use of partitioning in general, translating certain queries to point reads when applicable so that you can reduce the RU usage, and just so many improvements coming here. They're super active on GitHub and we love feedback. So please leave us any feedback on that provider if there's new features that you'd like to see. We also have a session state and caching provider. This is great for managing session state of web apps without requiring stickiness to any server. And this provider actually implements the distributed cache. So if you do want to store web session state, it's a great choice. But if you just need a distributed cache, you can also use this provider. And it's a great choice for getting your caching set up. All right. Next, we also have an Aspire component. Who's used Aspire? Couple people. Who's heard of Aspire? Okay, almost everybody. Great. Yeah, so we have an Aspire component. Aspire, as you know, is a cloud stack for building observable, production-ready, distributed apps. There's components for a lot of services that you know and love, including our Cosmos DB component, and I recommend that you check it out. And lastly, if you don't want to use any of these frameworks, components, you can also just use the SDK directly. So for the rest of the talk, we're going to be focusing on the SDK itself. So when you develop with the SDK, we have a logical resource model that allows you to interact with all of the resources in your account. This resource model is going to look really familiar from the first slide. So the first thing, the entry point to your account is your Cosmos client. The Cosmos client is thread safe and it performs efficient connection management, but it also has a lot of caches, metadata cache. It stores connections to all of your partitions. Remember, there's 4 replicas, so a lot of connections going on. And the Cosmos client is actually somewhat heavy. There's a lot of logic in this client. So when you create a Cosmos client, it's important that you create it as a singleton. If you have a multi-tenant application where maybe you have multiple Cosmos DB accounts for many of your tenants, you can, of course, create multiple Cosmos clients. But for each account, you should have a singleton Cosmos client. From your Cosmos client, you can interact with all of your databases. From there, you can interact with your containers. And from there, you interact with your items. So this is the resource model. It maps to the resource model of Cosmos DB, and this is what you'll see in the SDK. All right, so let's talk about one more concept before we dive into the code, and that is connectivity modes. There's 2 connectivity modes in Cosmos DB. The first is gateway mode. Gateway mode is available in all of our SDKs. And with gateway mode, the client uses HTTPS to connect through the Cosmos DB gateway, represented by the green nodes. Now, this is a multi-tenant gateway, so all the Cosmos DB accounts for a region can share the same gateway nodes. And that gateway actually is what's reaching out to your backend partitions, which is the blue dots. So for the blue dots, you can think of each partition, backend node. This is actually the replicas in your partition set, right? So you have this network hop, and that is what direct mode is built to avoid. So direct mode is available in the .NET SDK and in Java. It's not available in our other languages. But with direct mode, the client actually uses TCP to directly connect to your backend partitions. And if you remember our latency SLA, it actually is for direct mode specifically. So this is how we can guarantee super low latency, and there's no extra network hops here. But it does require opening a lot of connections. So if you have hundreds or thousands of partitions, each of them has 4 replicas, it's going to be opening a lot of connections onto your machine. So there are some scenarios where gateway mode may be a better choice for you, depending on your network environment and your setup. But these are the 2 options that we have. All right, so let's switch over to a sample app and let's see how some of this works in action. So I have Visual Studio open here, and I have a super simple sample app. This is just a console app, and I'm going to show you some of the options that we have in our Cosmos client. So first, you can see we're creating our new Cosmos client here. I'm just using my endpoint and my connection string, my key. Of course, if this was a real production application, you'd probably be wanting to use RBAC with Entra ID. We shouldn't be using passwords, but I'm going to use it today just to get started super easy. And I'm also passing in some options. So let's review some of the options that are offered to you through the Cosmos client. And the first one is going to be that connection mode. Oops. There we go. Direct mode. Okay, so direct mode is actually the default for the .NET SDK. So I don't need to set this, but if you want to change the connection mode, you change it through your Cosmos client options right here. And next, let's take a look at our consistency. So I'm going to set my consistency level. And let's go ahead and set this to session. Now, once again, session is the default. It is the default for all Cosmos DB accounts. I didn't change it, and so I don't need to set this. But if you wanted to tune the consistency, you can tune it in a couple of ways. You can tune it here at the client level, and you can also tune it at the request level, meaning each individual request can decide the consistency that it wants. There is a caveat. You can only relax the consistency. You can't actually increase consistency in the client or per request. If you want to increase the consistency and make it stronger, you need to do that at the account level. And then, of course, you can always relax per application. So it's recommended that you set the account to the strongest consistency that you want to use, and you can always relax as needed. All right, so what about the regions, though? Because I have 2 regions in my account, and how does the application know which region that I want to talk to? So I have a property called application region. And let's go ahead and set that. Let's actually set it to Central US. So when I set the application region, this is telling Cosmos DB, it's telling the SDK what region my application is in. Now, if I had picked a region here that isn't present in my account, that's okay. So when I set application region, all that it does is it takes all of the regions in my Cosmos DB account and it sorts them in proximity to whichever region I've selected. So if I had put East US, my regions would still be sorted with Central US and then West US. It doesn't have to be the region that exists in your account, but it just tells the SDK the failover priority and the priority for cross-region retries. This is really important because if you have a cross-region retry and it's going to some region that's super far away, it can definitely introduce latency into your application. So you want to make sure that you set this. And without setting the application region, it has impacts on the availability of your application. So we set the application region, but what if I don't want proximity for some reason? What if I have a region that I added really just for DR, and I know that it doesn't get used very often, so I know it has like spare RUs, or maybe there's a workload that's not that latency sensitive, so I want to set it up a different way. There's also the application preferred regions list. And with this list, I can pass a list of all the regions in my account. So let's say I want Central US and then I want West US. So with the application preferred regions, this one you do actually need to specify all of the regions that you have. So if I had a third region and I left it out for some reason, the SDK will also ignore it and won't reach out to it. So these are the two options. You can't set them both. You need to set one or the other. And if you do set them both, you'll get an error. So I'm going to go ahead and comment this out. But it just shows you how you can have more fine-grained control if you wanted to. All right, so that's our Cosmos client options. Let's scroll down and look at the rest of this application. The next thing we're doing from our client is we're going to get our database. And you'll notice I'm not awaiting anything here. It's not really doing much. This is actually just a metadata call. So this isn't calling out to Cosmos DB at all. It's just telling the client, what database I'm going to be interacting with when I decide to make a request. Now, you could instead do something like create database if not exists. And this will first check if the database exists. And then if it doesn't, it'll go ahead and create it. We don't recommend this in the hot path of the application. We do recommend that you just use the metadata calls. Typically, you'd create your database and you'd create your container outside of the flow of your application. But we do have that option there. It's helpful for getting started and things like that. All right, so let's get rid of this. Let's go back to get database. And next we have our container. So from the database, we can get a reference to our container. And then we're just going to do three things. We're going to create a product, we're going to read a product, and we're going to query our products. So taking a look at this query that we'll execute, we're going to get the top 10,000 items where the price is greater than 100. So I didn't tell you about this container yet, but it's a pretty simple product catalog container. I have a bunch of products loaded in here, and it's actually partitioned by category. Now, when I created the container, I created it with 50,000 RUs, which means there's 5 physical partitions in my container, and it's partitioned by category. So this is going to be a cross-partition query, and we'll look at how that affects our application in just a second. So scrolling down a bit to our create product async function. First, we're going to create a new product. It's my new product, and it's very cool. It was first available today. And I'm going to use the create item async API to go ahead and upload this document to my container. All I need to do is pass in the product, define my partition key, again, which is category, and then I'm good to go. Now, I have a couple of console lines here because I want to see how my request, how it went. I want to make sure the item was created. I want to see what the latency was and how many RUs it cost me to do this. And then I'll just print that to the screen. Scrolling down a bit, we have our read product async function. This one, very similar, also using my read item async API. This is also referred to as a point read. So if you hear point read, that's all it means, reading one document by its ID and partition key. And similarly, I'm going to print a couple of stats to the screen. So I'm going to get my latency and I'm going to get my request charge. And lastly, we can take a look at our query. So we passed in the query text, and we also have a couple of options. So you don't have to set the options, but if you wanted to change some of the options available, there's 3 that I recommend looking at. First is max concurrency. So the max concurrency is telling the SDK how many concurrent requests it can make at the same time. So this is really useful for cross-partition queries because we need to actually reach out to every single partition. If we set my max concurrency to 1, it means effectively all of those partitions are being reached out to sequentially. And ideally, we could reach out to them at the same time, right? So setting it to -1 will let the SDK decide what the best concurrency is for your application. And it's a great, if you don't know how many partitions you have, you can always just set it to -1. Next is the max item count. Now, it's important to remember that this is a maximum and it's not a guaranteed amount. So again, I set it to -1. I'm going to let the SDK decide. I don't have any specific number that I want. But say I did set this to something really high. Our query is getting 10,000 items. So what if I put this to 10,000? Cosmos DB has a response maximum of 4 megabytes. So even if I set this to a really high number, I'm not going to get more than 4 megabytes back in one request. So it's not a guaranteed number. It really is just that upper limit. The last request option here is called max buffered item count. Again, surprise, I'm setting this to -1 to let the SDK decide for me. But what the max buffered item count does is it tells the SDK how many items to load client side while I'm making that next request. Typically, we recommend that you set this to at least the number of your max item count or -1 if you want to let the SDK decide. So now that I've configured all of my options, I can get my item query iterator and I can iterate through my result set. For each round trip, I want to print a couple of things. I want to know how many items I got back, what the RU charge was, and what the execution time was. So how long did it take? And then at the end, I'll print one final statement for the entire application. All right, so let's go ahead and run this and see how it goes. And we can see, oh, we got a 403. Okay. Oh no, my firewall settings. All right, so let me go ahead and add this IP to my firewall. We love security here, so I can go into my networking settings here, and I can go ahead and add my IP. This operation does take a little bit of time, so that's okay. We're going to let this add, and maybe in a couple of minutes we can come back and we can run this again. But I will tell you, if this had succeeded, we would have seen that our create succeeded. It costs typically about 7 RUs for this application. Our point read would have cost 1 RUs, and we would have seen several round trips for that query. And all of this would have been printed to the screen. But in a real application, when you're just printing to the screen, that's not really a good way to monitor your application, right? I don't want to have to dig through console logs to figure out, oh, did something go wrong? Did I get an exception, right? There must be a better way to handle this. So let's flip back to the slides. And let's talk a little bit about monitoring. So why is monitoring important? As you can see, things can and do go wrong all the time. So monitoring really helps you understand what's going on under the hood of your application and gives you an idea of where to look to go fix something. It makes it easier to identify high latency requests, identify any operations that cost a lot of RUs, or identify if a specific machine or application is erroring more than others. One of the ways that you can monitor is actually through OpenTelemetry. So OpenTelemetry is an open source, vendor-agnostic instrumentation library with the ability to send data to multiple exporters through configuration. There's consistent APIs across languages and SDKs across languages. So this is a really great tool for monitoring. And it's becoming a standard in Azure Data and across all of the Azure SDKs. Most of them are all configured with OpenTelemetry, and it makes it really easy for you to see what's going on. This telemetry collection will be automatic, and you can send the data to any exporter of your choice. So my examples are going to send the data to Azure Monitor, but if you have a different APM tool, there's exporters for many of them, and you can easily configure. You can even send the same data to multiple exporters if you'd like. There's 3 pillars in observability. The first is distributed tracing. This is understanding what's going on with each individual request. And for Cosmos DB, we add a bunch of attributes to these traces that let you understand more about the RU charge, the regions that we've reached out to, some of the client settings, etc. There's also logging. For logging, we offer diagnostics logs. And you can set this up with either error, which means you're going to get the diagnostic logs anytime there's an exception, or with a warning. And we offer a couple thresholds that will let you determine when you want those logs actually to be exported. And lastly, there's metrics. So the Cosmos SDK doesn't support metrics through OpenTelemetry yet, but please look out for this. This is something that we're going to be adding in the near future. All right, so let's go back to the demo, and I'm just going to check on the status of that network update. Let's see. Oh, I don't see, so weird. I don't see the little notification. Okay, let's just try again and see what happens. This is a live demo, folks. Oops. All right, so before we change anything, oh, it looks like that didn't go through yet. All right, that's okay. It does take several minutes to update your IP, so. All right, so let's go ahead and see how we can actually configure OpenTelemetry. And I have a code snippet here that I'm just going to go ahead and paste into my application, and then we'll walk through what it's doing. All right. So the first thing that I did is I got my Application Insights connection string, and then I created a resource builder through OpenTelemetry. And this is going to, I've defined a service name, and this is going to really help me understand what service all my requests are coming from when I go to look at these requests later. I can configure the OpenTelemetry tracer provider, which is going to give me those distributed traces. And the OpenTelemetry support is still in preview, so I need to set this experimental switch, and I can configure my trace provider. I'm going to go ahead and add a source, which is azure.cosmos.operation. This is the source for operation level telemetry in Cosmos DB. And what that means is basically going to give you a trace for all of the API calls, and it's going to add a bunch of attributes to it. I then set up my trace exporter. I've chosen the Azure Monitor. So this is where those traces are going to go. And there's one more thing that I want to call out, which is the HTTP client instrumentation. So you might be thinking, wait a minute, we're using direct mode, which uses TCP, not HTTP. But even in direct mode, there are still metadata requests and several requests that the SDK will make to update the caches and things like that that are going to the gateway over HTTP. So there's still going to be some HTTP calls, and I want to make sure that I get traces for those too. After we've configured our tracing, we're going to set up logging. So I have my iLogger factory here, and I'm going to get my logging section to see where these Cosmos diagnostic logs are going to. Now, I have an example of my app settings here, which just shows you what setting to actually use if you want your logs to appear. So it's the Azure Cosmos Operation Request Diagnostics, and I've set this to warning. I could have also changed this to error if I only wanted logs on my exceptions, but I'd like to get warnings too. And there's also information. We don't have anything specific for information. It just uses the same as warning. So the two that are the two settings to remember are the warning or the error. All right, so now that I've gotten my logging section, I can go ahead and add OpenTelemetry. And again, I'm going to use that Azure Monitor exporter, which is telling where I want all of my logs to actually end up. And then I start my log forwarder. So the next thing we need to configure is our Cosmos client options. And if you remember, I said there are several threshold options for those warnings. This is where they're configured. We have our Cosmos client telemetry options. First, I need to enable the feature. We have it listed as disable distributed tracing because the default is false, and then we'll change that for GA. And once the feature is enabled, we can go ahead and set our Cosmos threshold options. There's two options here. First is for point operation latency. These are any of our specific operations that are going directly to one item. So this is our point read, our creates, our updates, anything for one item. And we also have a second threshold for non-point operations. This would be queries, change feed, anything for multiple items. And the reason that we split up these thresholds is because the expectation of latency is really different for these two types of requests. And we want to give you more fine-grained controls to determine, when do you want those logs to show up. Otherwise, if you have a bar that's too low, you might see way too many for your queries, which are in normal range, but your point operations aren't. So we like to split this up. And lastly, I need to actually wire this up to my Cosmos client options. So I'm just going to set my telemetry options, and I'm going to pass in that new variable there. All right, I'm almost scared to run this again. I feel like the firewall issue will not be resolved, but let's see. Yeah, that firewall is still there. Okay, that's fine. Luckily, I ran this earlier, and I do have some of my logs already in Azure Monitor. So we can go ahead and see what this looks like. So let's flip back to the portal, and let's open Application Insights. I have the application map pulled up here, and we can see this is my vslive service that I was able to run earlier. And I have two sets of things here. The first one is all of my application traces. Let's make this a little bit bigger. And this is giving all of the requests that I made into my application. So we see this feed iterator, read next async. Those are the queries that we issued. We have a couple item creates, and we also have read item async, which is our point reads. Now, if I look at the other set of items that are showing up on my application map, these are actually the HTTP calls. And these are the gateway calls that Cosmos DB is making to get all of that metadata. All right, so let's go back to our operations and let's go ahead and investigate performance. So I can see that the highest latency was for our read operations, that query. And we kind of expect that, right? Because we did a cross-partition query, there's a lot going on. But if we look at the create, 1.2 seconds seems really slow for a create operation. So I want to dig into this and I want to see what went wrong, what happened here. So if I click on this transaction, and I'll collapse this for a second, we can see the timeline of this operation. And we actually see a bunch of things going on. So it wasn't just the create. We also have these 4 HTTP calls, which if you remember, this is the SDK actually initializing all of the things that the SDK needs to function. It's reaching out, it's getting the container. So we have a GET request for our DB products collection. We have our PK ranges, partition key ranges. We have addresses. So this is all of that startup cost. And if you remember when we were looking at the metadata calls, so when we created our connection to our database and to our container, we did that via metadata. We didn't actually call out to Cosmos DB. So the first time we ever called out to Cosmos DB was in this create. So that's why you see extra latency in this create operation. Now, in the SDK, we offer you the option to initialize your connections before your application starts. So if you want to avoid extra latency on your first request, you can actually initialize before your data flow starts in your application. All right, so let's take a look at this create, and I want to see what are some of the attributes that we sent forward with this. So if I scroll down, we can see the database name. We're working with the DB database. This was a create. We had our container was products. And we also have this machine ID here. So what does this mean? If you're using a VM in Azure, we will actually give you the VM ID here. But if you don't have the VM in Azure or we can't get the VM ID for some reason, we'll just hash the machine name. And this allows you to see if you have a bunch of errors and they're all coming from one machine, it lets you know, hey, maybe there's a problem with that machine, or it just lets you know where your errors are coming from, if they're all coming from one or if they're spread across. Maybe your application is deployed on Kubernetes and one of your pods is faulty or something like that. We also have a client ID here. This is a unique identifier for the Cosmos client. So if you remember, we asked you to create your client as a singleton, but maybe you didn't create it as a singleton, or there's a bug somewhere in your code and you're creating a bunch of Cosmos clients. You can look at these unique client IDs to determine, how many clients do you have? Do you have the number that you expect? Or maybe there's a problem. We also tell you the connection mode that you're using. So we're using direct mode. And we see this as a create. Our status code was good. We see the request charge. We have the activity ID, which is the unique identifier for this particular request. And we also have regions contacted. Now, the region here is West US, and I swear I set my application to Central US. But if you remember, I only have one write region in my application, and that's West US. So all of my writes will go to West US, regardless of what I configured in my application region. All right, so those are all of the attributes. I also want to show you the traces. So if you remember, I set my operation trace threshold really low. I set it to 5 milliseconds. Of course, this took longer than 5 milliseconds, but I wanted to get those traces no matter what. And I wanted to be able to show you what the trace looks like. So if I click into the message, we can see that this was due to the latency being over threshold, and we get the request diagnostics. Now, this is sort of an eye chart. It's a little bit difficult to read, but this is really useful in debugging what's going on under the hood of your application. And we start with a summary here. So we can see the direct calls. These are the calls made in that TCP mode to your direct partitions. We had one call, it was successful. And we also see a bunch of gateway calls. So if you remember in our HTTP, all those extra dependencies underneath our main operation, these are the gateway calls that we had, and we have a summary here. So you can easily see, how many calls are being made. We have the name of the thing, of the operation. It was create item async. And there's a lot of information here that's really helpful in debugging. Again, the number of active clients, direct mode, the user agent, so we can see what version of the SDK we're using. And there's a ton of stuff here. I'm not going to go through everything, and it's not expected that you really understand how to go through all of the diagnostics. But if you wanted advanced troubleshooting and you wanted to understand what's happening under the hood, or maybe you filed a support request and someone from Cosmos DB asked you for this, this is a really easy way to collect it without needing to write any custom code. I didn't change anything in my application. I just configured OpenTelemetry, and I got all of this automatically. All right, so now that we can look at our traces and we can look at our application map, we see our performance. But what if I want to dig a little bit deeper? I promised you that we'd be able to answer a bunch of those questions, right? So how do we do that? With Azure Monitor, all of this data also goes into diagnostics logs. So you can actually query it with a couple queries. So let's delete this default query. And I have a few queries here that I've already written that I'll just copy in, and we can see if we can answer some interesting questions about our data. All right, so first, what if I want to see all of my high latency requests? So the first thing I'm going to do is filter by target, and this is my Cosmos DB account. And if I run this, I can see the top 10 high latency requests in the last 12 hours. And we can see a list here of what all those requests were. Most of them were those create requests, those read requests, right? So if you wanted to debug, what's going on, what's the most slow thing in your application, you can easily look at that. We also can look at some of those custom dimensions that we gave. So here we're also filtering by that same target, looking at my account, but I'm looking inside of the custom dimensions that we wrote, and I'm going to look at the request charge, and I'm going to just take the top 10 highest RU operations. Now we have, again, all of our reads took the most RUs. We can see how long they took, and we have all of the data about them here. You can expand this. You can see all of the custom dimensions that we exposed. These are all the same things that we showed in that transaction search view, but it gives you a little bit more programmatic way if you want to query, if you want to group by certain things, just makes it a little bit easier. Now, if we want to look at where the errors are coming from or the types of error messages, the types of status codes that we're getting, you can look at the custom dimensions using that machine ID column that we talked about. So here, I'm just grouping count of all of the requests by machine ID and also by status code. So you can see here, I ran all of these from my machine, so they all have the same machine ID. And I have a couple of requests for each status code. Here's that 403 that we got. So that was being logged. The logging worked. It just didn't actually make it to Cosmos DB. So that's good, right? This helps us debug what's going on in our application. And you also can take a look at the number of Cosmos clients you have. So here, again, ran this multiple times. So we see 3 unique Cosmos clients just because I was starting and stopping the application. But if you were looking for a singleton, maybe you'd expect 1 client per machine ID. So these are some of the questions that you can answer with OpenTelemetry and diagnostic logs. One more thing I want to point out is query. So we didn't take a look at the traces for the query, but my query had multiple round trips, right? We had actually 4 or 5 round trips in that same query. So what if I want to get all of those together? I just want to see, what does the full query look like? We showed you on the request level, there's something called an activity ID. For queries, there's also a correlated activity ID. And the correlated activity ID will be the same for all round trips of that query. So I pulled the correlated activity ID of one of my previous runs, and here I can see all of the round trips. Oops, I don't think I ran the right thing. And here I can see all of the round trips of that one query. So here I had 4 round trips for my query. I can take a look at all of them. I can look at the custom dimensions, how many items were returned. Obviously, I could write a much more complex query than this, but it's just to show you really the power of what you can debug once you configure OpenTelemetry and you have a better look at the monitoring of your system and what's going on under the hood. With Azure Monitor, you can build dashboards, you can build alerts. There's so much here. I won't show you all of it today, but this is just a little bit of information on how you can get more value out of your application, especially when you add the global distribution. You want to know what regions you're being contacted and make sure that everything is configured for the most performant way. All right. I just have one more slide, and that is the resources slide. So these are some of the resources. That first link is Try Cosmos DB. This is the link to the 30-day free trial without requiring an Azure subscription or anything like that. We have a link to some of the docs for getting started with the .NET SDK and also best practices using the .NET SDK. Many of the best practices we covered today, but we didn't get to all of them. So I really recommend you take a look at this. I believe the slides will be online too, so you'll have a link to those. And the very last thing is the session survey. Please take the survey. I do get the results. I will read them. I'd love to hear from you guys. And yeah, with that, that is the end of my talk. I hope you all learned something. Thank you so much. And are there any questions? I think we have a couple minutes left. Yeah.
Identities, like I'm running in the Azure function, and I'm trying to use the system side identity to access that, and it's blocking me into can't use a intro identifier to do basically the management plane execution.
Yeah. Yeah, so I'll repeat the question for everybody. The question is, if I'm using RBAC and I'm using Entra ID, create if not exist doesn't work. Unfortunately, yes, this is a limitation with the SDK today. The Entra IDs are meant for data plane requests. So when you're reading your data, anything like that is supported, but the management plane operations are not supported with the same Entra roles. This is something that the team is working on and will light this up over time, but unfortunately today it is a limitation. What you can do is you can add the management plane SDK and perform your creates through the management plane and have your data plane operations through the .NET SDK. It is a little bit clunky, unfortunately, but yeah, that is a limitation for today. Yeah.
Having not really worked with Cosmos DB, work on this on-prem SQL Server shop, but when it comes to doing things like reporting or the business units or anything like that, how would you do that with Cosmos DB, or is there like a guidance on how to do that?
Yeah, totally. So we have a lot of great analytics features. I don't know exactly what reports you're trying to build, but we do have Fabric mirroring. So we integrate seamlessly with Fabric, and you can build reports on Fabric, which is sort of built more for those analytical queries. In some cases, you can use some queries just right on top of Cosmos DB. We have like a Power BI connector and various things. So it really depends on what you're trying to do. But I think moving forward, the analytics story is tied to Fabric. Yeah. So Cosmos DB offers many different API types. Most of them are NoSQL, but we also have a Postgres API, which is relational. So there's one flavor of relational in Cosmos DB, but most of what I showed you today is all on JSON documents and NoSQL. Okay, any other questions? I'm sorry, can you repeat the question? Oh, okay. So the question is if two documents can be related in Cosmos DB. There's no direct relationship between documents, and we don't allow cross-document joins or anything like that in our query language. But you can have reference data in Cosmos DB. You can have, an ID that maps to the ID of a different document, but there's nothing native in the database that does that. So there's no management of foreign keys or anything like that. It's possible to build your own, and there are some scenarios where reference data is a valid scenario in Cosmos DB, but it's not out of the box.
IDs or something, then for example, in the database we have a composite primary key, which is also similar.
Yeah, so the question is about hierarchical partition keys and composite keys. Hierarchical keys is sort of the evolution of composite keys. So with composite key, you basically need to build it yourself. And typically for a composite key, you're taking two literal values and you're like concatenating them and storing them in a new property. Hierarchical keys allows you the same flexibility that the composite keys gave you with like spreading the number of values that you have, but it's more of a built-in and native way to do it. So they are different. There are some scenarios where maybe you still would want a composite key over a hierarchical key, but I'd say that in general, if you have a hierarchy or want multiple things to be part of your key, then hierarchical partition keys themselves is the way to go. Yeah.
Using the eventual or a less consistent model for getting data at scale, how do you know when you get the data back if it has been replicated or if it's actually gotten everything that the eventuality of it has occurred and everything's up to date?
Yeah, that's a great question. So the question is about eventual consistency and how do you know that like replication is done? So when you have multiple regions in your account, you will see something called replication lag, and you can look in the metrics and it will actually show you the replication lag. So how far some of your regions are lagging behind. That's across region. Within a single region, like the replica set, I don't think there's any way to know that all the replicas have gotten that change. I think you just need to like issue multiple requests maybe and see like, yeah, there's no great way. But across region, we do have a replication lag metric. Yeah.
Monitoring tools, is there any way to find out if partition keys are not correct? Like other monitoring tools?
Yeah. That's a great question. So the question is, are there monitoring tools to see if you've chosen a good partition key? Actually, my pet project is the Partition Key Advisor. And this is, it's been around for some time, but we're reworking it and it's not quite released yet. But we're building an advisor to look at your data, look at your requests, and tell you, how does your key stack up? Are there other keys that might be a better fit? We'll look at cross-partition queries. It'll give you an analysis of like, if you chose this key, here's what your cross-partition queries would look like. If you chose this other key, that's what it would look like. And we'll give you some information about your keys. So that's coming soon. It's not quite available. Actually, if you Google around for Partition Key Advisor, we do have a notebook, but it was based on Cosmos DB notebooks, which aren't around anymore. If you're interested, I can actually help you because we can rewrite. It's just based on a NuGet package that is like possible to run today. It's just the tooling around it isn't quite built yet. So that's one way. There is also partition key statistics table, partition key statistics table in diagnostic logs. So you can turn that on. It'll give you some information about your partition key diagnostics, like how full your partitions are, and things like that. So yeah, the experience is there's several things in progress to make that exact question a little bit better. There is a feature to change partition key. Right now, it's an offline migration. So basically, when you click change partition key, it will create a new container with a new partition key, and it will copy all of your data, but it doesn't do it in an online fashion. So if you have new writes coming in, they wouldn't be captured. We are working on online container copy that will allow you to change your partition key, and that is coming soon. I don't have a specific ETA though. Okay. Thank you so much, everyone.